At this point in the course, we have already studied kinetic friction. Kinetic friction is a frictional force which acts when there is already a sliding motion in progress. In this video, we're going to start to look at static friction. Static friction is a frictional force which acts when sliding motion has not yet begun. Static friction tries to keep that sliding motion from ever getting started in the first place. So to get started, let's say I grab the force scale here and pull so that the reading on the force scale is about 6 newtons. Now that 6 Newton reading on the force scale tells me that the string here is exerting a 6 Newton tension force trying to pull the box to the right. However, the box does not actually start to move to the right. And why not? Well, it must be because there is a 6 Newton static friction force pointing in the other direction, canceling the 6 Newton pull from tension. Now, let's say I increase the tension. So now I have 8 Newtons tension trying to pull the box to the right, which means 8 Newton static friction pushing the box the other way. Now I have 10 Newtons tension, 10 Newtons friction. Okay, so now 12 Newtons tension, 12 Newtons friction. And I'm just going to continue pulling harder and harder. And eventually, the box slips, right? Eventually, what happened is that the tension got to be so strong that static friction could no longer hold on. And despite the best efforts of static friction to hold on, the box slipped anyway. So let me do that again. And we're going to pay attention this time to just exactly where static friction got maxed out. Okay, so now we have 6 Newtons tension, 6 Newtons static friction, 8 tension, 8 static friction. So tension and static friction gradually increasing together. And right there, right around 16 Newtons, the box slipped anyway, even though static friction was trying its best to hang on and keep the box from slipping. Okay, so what this tells us is that right around 16 Newtons, static friction got maxed out. It could not exert a force any stronger than that, and so the box slipped anyway. Okay. Now let's say I flip the scale over, and this time I ask you again, what is the strength of the static friction force? Now, without seeing the reading on the scale, you cannot tell me exactly what the strength of the static friction force is, right? You could not tell me that the static friction force is 5 Newtons, 10 Newtons, whatever. So what could you tell me? Well, what you could tell me is that the static friction force is somewhere between 0 Newtons and 16 Newtons. Okay? So with static friction, we do not have a formula that tells us exactly what the static friction force should be in a given situation. Right? Static friction will be whatever it needs to be from 0 up to some maximum value to hold everything in place. Once static friction would need to be greater than that maximum value to hold everything in place, then static friction kind of gives up and the object slips anyway. Okay. So the next question would be, what determines that maximum value of the static friction force where static friction maxes out and then the object slips anyway? Well, we will discuss that in the next video.